All right, welcome to The Explainer. Today, we are diving into a coding concept that solves one of the most common, and let's be honest, frustrating problems that every new programmer hits. The program that just crashes for no reason. The solution is called casting, and trust me, by the end of this, you'll know exactly how to use it to make your code work just the way you want it to.
So here's our plan. We're going to start with a coding crash you've probably seen before. Then we'll introduce the simple fix, which is data casting. We'll give you a toolkit with all the right commands, see it all work with some real code, and then we'll wrap it all up with a golden rule you definitely don't want to forget.
Okay, let's set the scene. You're writing what feels like the simplest program in the world. All you want to do is ask a user for their age and then tell them how old they'll be next year. Easy, right? But then you run it, and it just breaks. So what's going on here?
This right here, this is the big mystery we're solving today. You ask for a number, you try to do the most basic math imaginable, and the computer just throws up an error. It's a classic coding puzzle, and the answer has everything to do with how computers actually think.
And this slide pretty much says it all. See, when a user types in 18, our brain instantly sees a number, but the computer, it sees text. To a computer, that's what programmers call a string. So you're not actually asking it to calculate 18 plus 1, you're asking it to add the number 1 to the text 18, which is basically like trying to add 1 to the word hello. It just doesn't work.
So how do we fix this communication problem? Well, the solution is an elegant but really powerful technique called data casting. It's how we speak the computer's language and tell it, hey, that thing you think is text, I need you to see it as a number. And that's really what it is at its core. Casting is just the process of converting a value from one data type, like a string of text, into another data type, like a number. The really key thing to get here is that we're not changing the data itself. We're just changing how the computer treats it.
Honestly, this is the easiest way to think about it. Casting is just a data translator. You're taking information that's in the language of text, and you're translating it into the language of numbers so your program can finally do the math you want it to do. Okay, so if casting is our translator, what are the actual commands, the words we use, to do the translating? Let's go ahead and build our toolkit.
These three right here are going to be your best friends. First up is int. Use that to turn text into a whole number, what we call an integer. Then you've got real. You might see this called float in other languages, but it does the same thing. It's for numbers with decimals. And finally, there's str, which is for when you need to go the other way and turn a number back into text.
All right, theory is great and all, but this stuff really starts to make sense when you see it in some actual code. So let's see casting in action.
And there it is. This is the fix for that first program that kept breaking. Now look really closely at that second line of code because that is where all the magic happens. So let's break this down. First, the input function grabs what the user typed. But remember, it saves it as text. Then, and this is the key, we use our int function to translate that text into a real whole number, and we store it in a new variable called age. And just like that, age is a number, we can add 1 to it, and our program works perfectly.
But what about a different situation? Let's say you're working with money, which usually has decimals. If you used int here, it would just chop off the cents, and that's no good. That's where our next tool comes into play.
And this is exactly why we have different tools. By using the real function, we're casting the user's input into a decimal number. This makes sure that if someone types in a price like $9.99, our math is going to be totally accurate. It's all about picking the right translator for the job.
Now, it's not just stuff that users type in that you have to worry about. Here's another super common place you'll need casting: when you're reading data from a file. Even if a file is just packed with numbers, your program is almost always going to read each line as a string of text first.
And this brings us to a really fundamental rule you just have to remember. Just like user input, data you read from a file is almost always treated as text by default. So if you're pulling numbers from a file and you need to do any math with them, you absolutely have to cast them first. No exceptions.
Okay, we have covered a lot of ground. So let's take a second to lock in all this knowledge and recap the most important things you need to take away from this.
Now, this is a super important detail to understand, especially for exams. When we cast that age text variable into a number, the original age text variable doesn't actually change. It still holds the text 18. What casting does is create a new, translated copy of that data for us to work with. It doesn't destroy the original, and that's a crucial distinction.
So let's just do a final recap. When do you need to use casting? Well, first,
anytime you get input from a user that you need to use in a calculation. Second, whenever you read numbers from a file that you need to process. And third, a slightly more advanced one. If you ever need to compare two things, they have to be the same data type. You can't really compare the number 5 to the text 5 without casting one of them first.
And that's casting. It's this essential skill of teaching your program to be, bilingual, to speak both the language of text and the language of numbers. And mastering it is a huge step that takes you from just writing commands to truly understanding how your program thinks about information. So now that you know how, what's the first bilingual program you're going to build? Thanks for joining me.